Hi, welcome to lesson 5.4, Equilateral and Isosceles Triangles. Now, you are going to need two pieces of half sheet of paper, and one of them is going to go glued on page 138, and the next one on page 139. So go ahead and pause the video and glue those sheets of paper. Now, on page 140, please set up a two-column proof for this right here. We're going to be proving what we call the base angle theorem. Okay. Now, at the bottom of page 140, you are going to evenly divide the space for problems 1 and problems 2. This is on page 140. And then on page 141, you are going to do 3 and 4 right there. All right, let's go back to our first construction, which is on page 138. Okay. By the way, if you hear noise in the background, my kids are outside the room making a lot of noise like always. So there you go. All right, construction. We are going to construct an isosceles triangle. Now, for this, you're going to need your compass and your protractor. Now, what I'm going to do is I'm going to turn this paper upside down. There's going to be a reason why. Okay, so I'm going to turn this paper upside down, and I'm going to pick a point somewhere around here. Doesn't really matter where. Okay. And what I'm going to do is I'm going to open up my compass to really any length that I want. Okay, as long as it's within the limits of the paper, of course. So what you're going to do is you're going to draw a big old arc. Doesn't matter how big, just draw an arc. Just like that. Okay. Now what I want you to do is turn it back up, like this. I'm going to label this point right here A. And I want you to pick 2 points anywhere on this right here. So I'm going to pick one right there, and I'm going to pick one right here. I'm going to call this one B and this one C. Now, one of the things that I do know about this, okay, is that the distance from A to B is the same as the distance from A to C. Why do I know that? Well, because it's the radius of a circle. So those two happen to be congruent. Now go ahead and finalize your triangle by joining the segments from B to C. Okay? All right, so here's a little bit of vocabulary. Actually, before we do the vocabulary, let's look at this angle here and this angle here. If I wanted to measure them, all I would have to do is measure. Okay? So this one is about 50 degrees. Okay. Now if I look at the second one right here, it's going to be about 50 degrees right there. So here's this. These two angles right here are congruent. All right. Now that's going to be my conjecture. We're going to be proving that in a little bit. Okay. So our conjecture, okay, is that the base angles, I'll talk about what that is right now, the base angles of an isosceles triangle are congruent. All right, so what are the base angles? Okay, this angle right here and this angle right there, those are your base angles. Okay, so you would say that it's the non-included side between these two sides. okay, which makes this also the base. So these are the base angles. They're the ones that are across from the two pairs of congruent sides. Okay. So if these two are congruent, then the sides opposite of those are going to be congruent as well. And that's one of the theorems that we are going to be actually looking into. So that's your first construction here. Okay. Now our conjecture would be that angle B is congruent to angle C. And we're gonna show that later on. All right, next construction, turn to the next page, page 139, is we are going to do an equilateral triangle. All right, it's actually a very simple construction. First thing you need is you need a side. Okay, so give yourself enough space. Create a side, doesn't matter the size. Okay, call that A and B. And here's what you're going to do. You are going to measure this segment from A to B. Okay, measure it like this. And then what you're going to do is you're going to create two arcs from both A and B, and they're going to intersect somewhere on top. So look, here it is again. You measure it from A to B, or B to A, doesn't matter. Create an arc from B, create an arc from A. Don't do it too big. All you need is just the intersection. And this point of intersection is going to be C. So the thing is, the distance from A to B is the same distance as it is from B to C, because you know the circle going this way. And same thing for this one. So look, all of these are exactly the same. Now I'm just curious, what is the angle measurement of each? Okay, well if you look at it, okay, if you measure it really, really good, this one is 60 degrees. This one right here is also 60 degrees. Take a wild guess. What is this angle going to be? Also 60 degrees. So this triangle here happens to be equiangular. So our conjecture, okay, is that an equilateral triangle is equiangular. Okay, equilateral, equal sides, equiangular, equal angles. That means all of these are 60 degrees. Okay. All right, let's turn to the next page. Okay, so let's look at the theorems first before we actually prove this one. Theorem 5.6 says the base angle theorem. Hold on, sorry, my mic is very sensitive and I had a helicopter go above my house, so it was loud. Okay, so the base angle theorem. If two sides of a triangle are congruent, then the angles opposite of them are also going to be congruent. In other words, if you have a triangle like this one right here, okay, that is an isosceles triangle, the angles opposite of those two congruent sides are going to be congruent. So if AB is congruent to AC, then angle B is going to be congruent to angle C. And this is what we're going to be proving above here in just a minute. The converse of that, if two angles of a triangle are congruent, then the sides opposite of them are also congruent. So if you have a triangle where these two angles here are congruent, then that will imply that this side and this side are going to be congruent as well. We're not going to prove this one, but we are going to prove this one in a bit. Now, on the next page, we have two corollaries. The corollary to the base angle theorem says if a triangle is equilateral, then it is equiangular. And its converse If a triangle is equiangular, then it is equilateral. We're not going to prove it, but it's a very, very easy proof to do, by the way. All right, so page 140. Let's look at how on earth we are going to prove this. It's not too bad, okay? But let's look at it. So the first thing we're going to do is I'm going to draw this diagram a little bigger so we can see things a little bit more clear. So I'm going to draw this a little bit bigger. Okay, I'm going to call this A, B, and C, and these two are congruent. So it's the same thing. That is right here. Same thing. All right, so here's what we're going to do. We are going to draw, okay, an angle bisector. Yes, you heard me right. An angle bisector for angle A. So the angle bisector is going to go something like this. Okay, now the angle bisector, what it's going to do, it's going to make this angle and this angle here congruent. Now this point of intersection, I'm just going to call it D. Now my goal, guys, is to prove that this triangle and this triangle are congruent. Once I prove that they're congruent, then their corresponding parts are going to be congruent as well. All right, so step one. Okay. What we have here is, in the given, is that AB and AC are congruent. That's given. Now, what is not given is that angle bisector. So, AD, okay, is an angle bisector. And we call that an auxiliary line. Okay, what is that? It's a line that we add to the diagram that does not change the diagram. It just enhances it. So it's auxiliary line. It's not a theorem. Okay, third, because it is an angle bisector, you are going to have angle BAD and CAD congruent. So angle BAD, okay, BAD congruent to angle CAD. How do we know that? Well, we made it an angle bisector, so therefore the two angles are congruent. So definition of an angle bisector. Definition of an angle bisector. Now take a look at segment AD. AD is also congruent to itself. So AD, oops, excuse me. Sorry about that. It was my mama. She called me. All right, so where was I? Okay, so AD is congruent to AD. Okay, and that is because of the reflexive property of congruence. Okay. All right, so check this out. You have a side, you have another side, and an included angle. So therefore, the two triangles are congruent by side angle side congruence theorem. This is what we learned in the last section. Okay, so triangle, okay, where is it at? BAD congruent to triangle CAD by the side angle side congruence theorem. So look, these are congruent. So because we know that they are congruent, their corresponding parts will be congruent as well. So therefore, angle B and angle C are going to be congruent. Angle B and angle C are going to be congruent. Now, this is the part that you're going to be really confused on. Okay, so it's an acronym, CPCTC. Okay, so what does CPCTC stand for? All right, write it up here so you can see it. Hopefully you have enough space. Okay, it stands for this. Corresponding parts of congruent triangles are congruent. So what does that mean? It means that once you prove that a set of triangles are congruent, then their corresponding parts are going to be congruent by definition. Here, we already proven that triangle BAD and triangle CAD are congruent. Therefore, angle B and angle C are going to be congruent. Now, instead of writing all of this right here, we use the acronym CPCTC. Okay. Now, remember, CPCTC is not a theorem. Okay. It's a definition. Okay. It's called corresponding parts of congruent triangles are congruent. All right. Let's go ahead and start our examples. All right, example number 1. Okay, in example number 1, it says, in triangle DEF, DE is congruent to DF. Name 2 congruent angles. So here's the thing. One of the theorems that we did learn is the base angle theorem. Base angle theorem says if 2 sides are congruent, then the angles opposite of those are going to be congruent as well. Okay, so that means that this angle and this angle are the congruent angles. So angle E congruent to angle F. That's it. That's all you have to do for number 1. Okay, all you have to do is look across and identify the base angles. So that would be this one and this one. That's number 1. Number 2, find the measures of angle P, Q, and R. Now, one of the theorems that we did learn, it's actually a corollary. It says if a triangle is equilateral, then it's equiangular. That means that all these angles are going to be the same. So if the sum of the angles is 180 and they're all the same, 180 divided by 3 angles is going to be 60. So the measure of P, the measure of Q, and the measure of R, they're all going to be the same, and they're all going to be 60. Okay? All right, that's example 2. Let's look at 3. For 3, it says, find the values of X and Y in the diagram. There's a lot going on in this diagram. Okay, first off, let's look at this triangle right here. The top triangle right here is telling you that it's equiangular, which means that it's also equilateral. So that means that this side, and this side, they're all the same size. So that automatically gives you the value of Y, which is 4. That means this is 4. So 4, 4, and 4. Looking at this triangle, these 2 angles right here happen to be congruent. So the sides opposite of those are going to be congruent as well. That means that this side and this side are going to be congruent. So that would mean X plus 1 is going to equal 4. So X plus 1 equals 4. U minus 1, and X equals 3. And then you're done with that one. That's example number 3. All right. Now this one, it's a little bit more complicated. Okay. So I want you guys to pay very, very close attention to this one. Let me zoom out a little bit so you can see they're asking me to do 2 things. Now I know the diagram itself is not that good, okay? But I'm going to recopy the diagram right here at the bottom so you can see what I'm talking about. Okay, it's going to look something like this. You have P, Q, you have this one right here, S, and you have this one right here. Ugh. I have not an expert drawer, but I'm doing my best. Okay, much better. Let's ignore that. Okay, so you have R, you have T, and you have angle 3, angle 4. Okay, and 1 and 2. Now, they're not asking me to do a formal proof. They just want me to explain. Okay? So it says, according to what I'm given right up here, PS is congruent to QR. So PS and QR, they're congruent. Also, QPS, that's this one right here. Let me use a color. This one right here is congruent to PQR. This one right there. And what they want me to do for this part is explain why QPS and PQR are going to be congruent. Okay, so let's look at one thing. Let me separate these. Okay, so if I were to separate these, okay, I have P, Q, S, and the other one looks something like this. Man, that's not even a triangle. Okay, and you have P, Q, R. Based on this one and this one is congruent. This angle and this angle are congruent, and that's all they're giving me. I want you guys to notice one thing. Isn't PQ and QP the same segment? Yes, it is. So that means that this side is congruent to that side. So therefore, you have PQ congruent to QP. And now you have side angle side, side angle side, and therefore the triangles QPS is congruent to triangle PQR by the side angle side congruence theorem. Now, this isn't a formal proof, but we could turn this into one. All right, for the next part, explain why PQT is isosceles. Okay, so let's look at PQT. PQT is just this little part right here, this one. P, Q, and T. Now, this angle here is going to be angle 1. This angle here is going to be angle 2. According to the diagram, this here is angle 1 and this here is angle 2. Now, because we just proven that the triangles are congruent, okay, angle 1 is congruent to angle 2 by, do you remember what it is? CP, CTC. Corresponding parts of congruent triangles are congruent. Okay, so up here, the triangles are congruent, therefore 1 and 2 are congruent. So now 1 and 2 are congruent, okay? And by the, what's it called? The converse of the base angle theorem, PT is going to be congruent to QT. Okay, this is by the converse of the base angle theorem. Okay, therefore, PQT is isosceles. All right, and this was example number 4. Please make sure you guys work on your extra practice, okay? And I will see you all later.